Hello? Oh, okay. Uh, Good evening, everyone. Thank you for coming to see us today. So, uh, before, what I'm going to be presenting today is our model for an affordable housing design. It's like a prototype, basically. So, what we're trying to show is like industrialized building system combined with rethinking of some of the urban planning paradigms can lead to a solution to how to create more affordable and social housing in the country. So hence from home owning society, which is what a lot of Malaysian pride our country has. So we're saying that we should be a home building democracy. All right, okay. So before we start, can I ask everyone to download a QR code scanner? I will tell you why. But if you are using Android, yeah, this is it. If you use iPhone, that's it. I'll show you why it'll be useful later. So housing is architecture for the people writ large. It's like it's the first thing you would see in a country when you travel or something, and it has some. It's a reflection of what kind of society it is. You know, like countries with no social and public housing, you kind of know what kind of political system that governs it. And Malaysia, fortunately, once upon a time, boasted a very proud history of social and affordable housing until the 1980s when privatization gripped this country, if you like. But the 21st century presents a different type of problem. So we can't be doing the 1970s model just like that. So this is the current situation with house prices. If you look at the current house prices for B40 and M40, this is what people can actually afford, and this is what actual price is like. So houses are severely unaffordable, and I think if you're young, you know that. You don't need these graphs to tell you. So what we are saying is, when you look at the price of housing or apartment, for example, you must look at it in different scales. So if you look at the micro scale, this is the actual cost to build the building, you know, like the materials, construction method, and all that. And meso, what we call as meso scale, is the facilities that you need to service the community. And on a macro scale, of course, you're not building the whole city, but on an urban scale, it has an effect on the building that you have to build. So let's say if it's a very car-oriented city, you have to build huge car park podiums, and it's actually 39% in some cases. So imagine if you buy a house, about 40% of that house price or cost of construction is to build car park podium. And to get rid of that, you can't just simply not build it. It's a disentangling of an entire spaghetti junction of regulation and urban planning rules. So this is what we've built. When we build high-rises, we think of corridors, especially for architects, we really think of corridors as simply a place to just transport people, so it has no other function. So you find this, including where I live, in Ara Damansara. So that is the life that you would have to endure if you live in an apartment, most apartment. But what high-rises and apartments should be is they should learn from the spirit, the physical, visual, and emotional life of a kampong. So the neighborhood, which is always something that we try to create in our architecture, is actually consists of this soft tissue of intricate web of interactions, your daily chance meetings and a conversation and things like that. I think everybody knows this. So what we set out to do in the competition is to learn from the ordinary people, to look at PPR, social housing, affordable housing, the current stock that we have, especially the older ones, and learn, we say learning from Las Ceras. So as a, architects love it, as a pun on Venturian book, Learning from Las Vegas. So the corridors especially is something that we were interested in. We look at the corridors in Singapore and Malaysia. It's not just an access route, it's a front lawn, it's very lively. People do all sorts of things. And this one captured by a photographer, there's a lion dance and sometimes funeral and all sorts of stuff happens in the corridor. A lot of people who grew up in high-rises, their childhood consists of a lot of playing in corridors. It's a small extension of your house. But unfortunately for architects, when we design corridors, we don't think of corridors in such a way. We don't think of it as an articulated social space. So we are also quite fascinated by the bamboo poles, which is a very unique phenomenon in Asia, mostly. Singapore actually regulated it and integrated it into their HDBs. In Hong Kong, it's still all over the place. It's not clear whether it's fully regulated. But if you've lived in HDB, you'll see these bamboo poles kind of integrated at windows and backyards. So the corridors, if you look at it as a cross-section, is a story about that community. So there's a lot of life going on there. So it is from this understanding of corridors as a social space that we were driven in the beginning. But so how do you design this social environment that we so desire in apartments? So it's a long-standing debate. I mean, we're not the first person to think about it. It's a tradition in modern architecture. So we look at how do individual units combine the kind of works in a continuum into the common facilities and then going into the public sphere. So how do we connect all these different spaces, which normally creates all these atomized apartments, sort of warehousing of people? We want to connect all these different tissues. So we think it's important to create a social corridor. That's I just said just now. And then how do you make that corridor respond to kind of daily chores of life, you know, like laundry, talking to your neighbors and planting a pot of plant? And how do you then, from the public sphere, connect the individual units into the public sphere, basically, through the ground floor? So we thought of a pedestrianized, transit-oriented ground floor, which will connect the building to the rest of the fabric of the city. And also, which you will see later, we wanted a mobile app, which kind of give you a Netflix way to see housing. So because we wanted an affordable housing, a social housing model, we thought of we thought of strategies of cost reduction. So the first one that we must do is to increase the efficiency of construction through the use of industrialized building system, IBS. So these are prefabrication, precasting, and combine that with a kind of digital manufacturing that Gamuda IBS has. And secondly, to omit the car park, because that's a massive cost to construction, about 39%. But to do that, of course, there's a long way. It's not just getting rid of it. We need solutions on a micro and macro scale as well. And then use the IBS to create a standardization without creating the monotony. So how do we create standardized elements of precast without creating the stigmatized image of precast architecture? So, and finally, we wanted to test the idea of incremental construction. So basically, idea we saw in Chile. So you just build a third of the house, the other 2/3 will be built by the owners once they have more money and they have the time to do it. So as a whole, when we combine it, it becomes a kind of like design mandala, like how to think about social housing. So integrating cost reduction with the social ideas that we had. So this is our concept, if you like. So the social corridor, as I just said to you, this is kind of like early stage collage. So we thought of the interaction between the mezzanine floor to the corridor, and then having a threshold space, an idea we took from Hermann Hertzberger. So before it spills into the corridor, and having the corridors punctuated with seating and areas where you can do laundry and possibly plant some pots of plants and things like that. So the idea is to have an augmented version of the corridor, which is normally just straight, right? So these are some of the options, how you use the what we call bamboo poles, these protruding platforms. So this is some of the imagination of architects. So okay, so so if you look at the blue area, that's the unit of the house. So this is the corridor. So we created a kind of slow progression from the public area, the corridor, into a semi-public area, and then into a private unit. So this slow progression, this threshold and spaces will, well, inspired by Hermann Hertzberger, will create the kind of activities that needs to happen in the corridor. So it helps to spill the activities of the units. So we also clustered them. So because looking at some of the problems of the PPR, these vast corridors and vast blocks with so many units, it creates isolation actually. So after a few number of units, you really don't talk to your neighbors. So we wanted to cluster them and then create a small community along the social corridor. So this is what we tried to present the other day, which is our tiffin model. So tiffin, if you don't know, mangkok tingkat, comes from Urdu, if I'm not mistaken. So it is an analogy of what we're trying to do. So building on top of each layer. And I think when you say tiffin or mangkok tingkat, people understand it as a shortcut. So why this is important for the idea of creating affordable housing is that you only build the base unit. So this is what you purchase from the developer. When you have more money and more time, you can self-build later. So to create that, of course, you need, there's a lot of problems in a high-rise construction during, you would know this if anyone has done partial CCC and ideas, things like that. So construction access is paramount to this kind of idea, and how to bring the logistics of the construction elements also bear one of the main problems. So we tried to, we took it as a challenge to how do we do this kind of tiffin model. So of course this is not new. Alejandro Aravena is the most recent example. His half houses in Chile. And much older and much more sophisticated is Balakrishna Doshi from India. Both are Pritzker Prize winners. So they did incremental housing many years ago. So this is what the house will be like. So you start with an 855 square feet house, 1 bedroom, 1 bathroom, a bit like a studio, a spacious studio. And then as you upgrade, it becomes 2,500, which is very spacious, actually. And as far as affordability is concerned, which is the moment when you have to do the transaction, you only pay that much. Oh, God. So, yeah, this is the usual architecture stuff. So we broke up the blocks as to create permeability and allow sunlight to penetrate all the way down, because one of the main ideas is to allow these bamboo pole platforms to have sunlight. Otherwise, it kind of defeats the purpose. So, of course, connection to the urban fabric. So we really try to make it as connected to the urban tissue as possible. So hence, the permeability of the ground floor and creating an active frontage is crucial. Okay. So these are the typical floors. There's two types of residential floors. One is the residential unit floor, which has the social corridors and the housing units where you can upgrade. And the other one is called transit floor. So the transit floors are almost like hotel rooms. So they are meant for co-housing. So I'll show you in a bit what that means. So this is mostly for first-time house buyers or rental market where you can't afford to buy a house yet, but you can stay in a small room with shared facilities. So this is the typical unit. I think I've shown it before to you, corridor with an anjong that spills into a wet kitchen, and you have a dry kitchen, and this is the unit. This is the area for the staircase for your future construction. So that's what it looks like. So this is the transit home. So co-housing where you rent like a room and then you have your kitchen and living room sort of shared along the corridors, creating an even more lively corridor than the residential floors. So that's what it looks like. So of course, the facade will constantly change as people do whatever they please and however they want to renovate their homes. So it's not necessarily going to be like this. All we did is just a basic infrastructure and structure with the base units. So this is the view of the internal corridor. So the elimination of private vehicles and turning it into a car-sharing community would allow the omission of the car park podium, because we did calculate for enough cars to be used in according to the regulations, like one-to-one kind of stuff. So we did have enough cars to be parked, but it's all in mechanical parking, and it's not privately owned. So you can only use the car if you have a sole car. So it's a car-sharing future where nobody owns a car. It's a kingdom of heaven. So the next one is we also included working spaces, co-working spaces as an idea. And where you don't have anything built yet, it can be used for other things like gardens or barbecue areas. So it's able to support multiple users. So this is how things are constructed. I will talk to you about it more detail in a bit. So see a forklift bringing the prefab elements with a gantry, and then where it's actually built while life goes on. And also, I forgot to say, we link it to a mobile app, which I will show you in a bit. So that's the overall form. Again, this facade is we really didn't think about facade. Well, we didn't think about it. We thought of facade as a kind of ever-evolving phase. So one of the most important process that we went through is to ensure that all of the prefab elements and precast elements are linked to the manufacturing capabilities of the factories. So it's not just about creating the elements and then expecting it to be built and manufactured. So we really looked at what the factories can do. So just to recap, so this is what you get when you buy the house, and then as the time goes by, you add more units on top at your own pace. So this is how the process of the prefab area. Right, so this app that we wanted to show you later allows you to look through all the elements, prefab elements like IKEA, like Lazada even. So it creates a whole new way to think about construction. So when you buy the prefab elements, the lorry will go into the loading unloading, goes into this massive lift that you see in factories sometimes, and then it carries all the way up along with the forklift who picks it up from the truck, and then it carries it through the construction corridor and then brought to the site of the house. So as you can see, this is a forklift. This is a temporary gantry that has to be installed. We have all these ideas about pre-casted elements where you can just like slide the mobile gantry in and all that kind of details. And this will carry the elements one by one, creating this construction process. So a lot of the details were important. So we really thought it's important to have steel junctions so that you don't drill into the concrete and then, you know, disturbing a whole community while you're renovating. So a steel member would, what do you call it, would allow the first few slabs to be installed without creating such racket. So again, that's a. So the floor plans are optimized to the fabrication machines and techniques. So what do I mean by that? So if you've never been to a precast factory, so it has a plate, like a big plate, and then it has this concrete spewing machine, and these red things are shutters. So these shutters are placed on the plates, creating a kind of border, and then the concrete is thrown into the creating a pool of concrete and hardens and becomes the wall panels. So these wall panels are optimized so that every time they have to do the precast, the plate is maximized. So we really went back and forth from design to element design so that it's maximized. So we also wanted all the elements to be as standardized as possible so you can create an economy of scale. So this will bring down the cost of housing. And when we have finishes, we make sure that the finishes follow a 1 foot rule so that it's zero waste. So and also a very fast installation. Of course, the M&E stuff, odious, nobody's interested in it. We spend a lot of time trying to solve rainwater downpipe. How to create the junction, because if you think about it, it's like tanggam, if you know all these wooden junctions. To create a hole for the rainwater downpipe is quite a fascinating thing, but when you see it come together, it looks just like that, but pretty fascinating beam experiment. Okay, so of course we have green corridors that stretches from up to top to bottom. We really thought of storm and rainwater management. We use landscape design strategies to store stormwater, etc., etc. OSD tank, you know. So pedestrian-centric environment, that's very important to us to complement our idea of abandoning the car. That's the plaza that we create that links all the way into the heart of the city, the building. Passive cooling, of course, because of the permeability of the building. And we did a test on solar heat, so it's reduced by a lot. We oriented it, you know, the usual architecture school stuff. So, and because of our orientation of the blocks, this is the lowest floor, level 1, I think. Yeah, I think it's level 1. So you still have a decent amount of sunlight with the this X configuration. So if you have QR code, you can try this, and you will see the app that we've built to show you how the full environment and the full digitization, and I call it Netflixization of housing could work. I don't know whether, anyway. So you go in and you can actually log in to the fake Gamuda IBS page, which looks like IKEA, and then you can choose your housing unit. Just follow the red links, because that's the only thing you can click on. So if you click on it, you can choose what type of unit, what type of development, and what you want to buy. So within a limited form of elements, you can create a high degree of customization. So this is what we wanted to show. So before I end, I just want to give an ode to the team. So these are the team of people who worked on it. And I think some of them are here. Thank you very much. And if you have any questions, maybe in the Q&A session. Thank you very much.
Thank you, Pak Ihsan. Everyone, let's give another heartwarming round of applause.
Good evening, everyone. Okay, I'm Syihan, as what has been introduced by the speaker. Okay, first of all, I want to thank Pam, the organizer, fellow organizer, for inviting me, giving us the opportunity to share a little bit of the story behind the Living Cubes scheme. Yeah. Okay. Everything started with this. Okay, we started by doing this by looking at the city mapping of Kuala Lumpur itself. Okay, the most densely populated city in Malaysia, right? Okay, looking at this, by doing all this layering of analysis, we identify nodes, interconnectivities, linkages, and we came across this figure ground analysis, right? So if you're looking at this figure ground analysis, you see all these little dots, nodes, cubes, or whatever you call it, is actually habitable spaces, right? Be it some residential, offices, retails, anything, but these are all the spaces where people live in. Yeah. So based on this analysis that we did, we see that this urban fabric is giving us conceptual possibilities. And the cityscape itself is showing, is giving us, we see rhythm and interconnectivities. And the figure ground itself, the one that we overlaid just now, is giving you an idea of a scale and volume. So we start to discuss internally, okay, how these conceptual possibilities can be a physical reality, and how this rhythm, interconnectivity can produce a metaphor or a ideology, and how the scale and volume of all this, the figure ground, contributing to human comfort and harmony of living. So moving forward, we start to play around with this by conceptualizing a ground plane based on the mapping studies that we did. We then move forward, forming the ground plane into a rockscape articulation based on the abstract interpretation. And we then see, we then notice that all is allowing, we somehow creating this interesting spaces in between. So giving the opportunity for greens, landscaping, and activities to happen in between. Yeah. So that is where, to summarize, that is how the name of Living Cube came about. So the name Living Cube comes from the idea of bringing life from something still. That's very conceptual. Yeah. So the abstract notion of it, the Living Cubes, is to challenge convention and to set polemic for others. If a current city is formed through addition, this building is could represent the opposite. So it's a piece of development formed as natural as it may seem, anywhere, anyhow, wherever there's opportunities. So the design is very straightforward. Okay, sorry. Very straightforward. Develop two simple strategies: horizontal layering of spaces, defined by function and access, and also vertical habitable spaces cutting from the solid. Right. We always started with a very simple diagram. Yeah? So the mass block being articulated, pixelated to carry and reflect certain scale of this a certain scale for inhabitants not to feel alienated from the neighborhood. So it's a play of scale. The whole idea of this, of the figure ground, is giving you an idea of how the play of scale and its rhythm, which is also inspired by city figure ground, is the narrative that create the interesting dialogue between overall landscaping. So the idea is to have a quality of a house on ground but up in the air. So that is a quality of a house that you live in. It's like a bungalow up in the air. So that is a big idea of it. Yeah. And every single spaces that we do, the whole idea of the scheme is to elevate the living quality of the inhabitants. So we started also by overlaying the overall mapping into the overall context. The overall site is an imaginary site. I think the site was created. Okay, so by overlaying the whole thing, we're creating opportunities how to link the whole neighborhood together. You see, by introducing interconnection, desired path, placemaking, so on and so forth. So as we go along, we start to identify and link up the whole township neighborhood with linear park, placemaking, adopted park, and recreational park. Yeah. So again, every single spaces that we're creating is for the people. So we started to carve out the ground plane by creating a pocket garden all the way down to the undercroft. So the basement will no longer be a dark dungeon anymore. So in between the car park area, you have all the greens, you know, again, and we're keeping the ground plane for the residents, placing all the amenities and facilities. As you go up, there will be at certain intervals, there will be a vertical garden, sky terraces. All of this is for the people, quality of space, and also visual buffer for all the apartment units. Just a very clear diagram of the overall section. We are elevating the ground plane, keeping all the back of house on the side on the ground plane, and also by elevating the ground plane, you're actually giving a better, grand sense of arrival to the building. And also we are placing landscaping and also water body in most of the area for evaporative cooling and giving a more comfort microclimate throughout the building. As we mentioned just now, the green area, opening the ground plane, bringing the green all the way down to the basement, allowing skylight, natural ventilation throughout the building. I'm going a bit fast because I was looking at the time. So, yeah, right, okay. So the overall development is an organic development. It might not look very organic, but we call it organic development because the whole development is controlled by certain organizational structure that we created. So this organizational structure becoming a system, so this system shall then grow naturally wherever there's opportunity. We are lucky enough to get the site which is quite linear. So to give you an idea, the whole plot is controlled by the linkage and connectivity, becoming a backbone of the whole development. So the whole, the corridor becoming the main backbone, the linkage, and all the residence units attached to the main linkages, and at certain interval there will be a green areas, which replacing every single unit at different spot, different levels. All right, we always emphasize on human experience. So the idea of having all these green areas, sky terraces, is actually to elevate the quality of life of the inhabitants. Yeah, so every opportunity that we get to open up, to take out one of the volumes, we're introducing landscaping, water body for the comfort level of the users, and at the same time, every movement of the units will create landscape, green area, vertical garden, which also becoming a we're becoming a green, So every movement of the unit will create a vertical garden at the back of your unit, will becoming a buffer to every individual unit. Okay? Right. My friend Ihsan is talking a lot about corridor just now. So the idea of living cubes is to create a healthy living to the inhabitants. So we also try to trigger more collaboration, interaction between the users, between the residents. So you're no longer talking to just your neighbors next door. You can actually interact with your neighbors on different floors, as you go along. And we're bringing this light in all the landscaping area, very, very active spaces that you see. Right. To put it in a simpler diagrams, everything is linked up with this main corridor. Secondary corridor will take you to all the individual units. And at every interval there will be a green area, and every and all the residential unit is built within a volumetric module. Every volumetric module house 2 different type of unit, as what given by the brief, right? Okay, so this residential unit or habitable spaces represent a inner volumetric module, which similar to a scale of any habitable space on land, and connected to the main linkages of corridor, almost like a parasite attached to its host. We only have 2 types of unit, that's it. Type A and Type B housed in one volumetric module, which is the cubes that we're talking about. And in between spaces, one of the volumetric modules is taken out, replaced into a garden or communal area. And we start to introduce greenery, landscaping, water body in this sky garden, allowing prevailing winds to cool the interior space, which giving a higher comfort level throughout the floor. And there will be certain system which I'm not going to go in detail. Every movement, every typical floor will have their own rhythm, which following certain rules, the projection and also the movement of the units. And this is what we're introducing to you. Living cubes is control, is becoming a system which can be built anywhere, at any plots, at any areas. And we are going away from this monotonous, repetitive and banal architecture, introducing flexibility, personalized and robust architecture. The living cube can be built in various locations, site condition, limitation. The living cube can also be altered to accommodate budget and constraint. So the idea is this: in Malaysia, it is very distinct to see luxury apartment, condominiums, affordable housing. So what we're trying to say is, regardless of all these different group and quality, the living cubes can be adopted to all. All right. Budget, cost, material, but this system can be applied regardless of any status and any level. Yeah. And we always believe on good example. So in this case, it's a good exercise that we're also talking to the specialists, to people who knows to do things like Gamuda with the IBS system. So we learn a lot along the way, building modulation, IBS, and engineering. So we're looking at this as one integrated design strategy, one volumetric module, housing 2 different type of unit with a modular structural system and centralized MEP system. So what we're trying to do is every single structural member, every single precast structural shear wall is a sandwich structural shear wall, which housing all the MEP shafts all the way down to the ground plane. We proved that the analytical structure model works. All the shear walls going down to the ground plane, transferred to the typical precast columns. And we also run this structural integrity simulation, which proved that the maximum deflection is within tolerance. So regardless of any movement of the building, with the rule and system that we're introducing, it works. And again, I'm almost coming to the end of the presentation. Yeah. So residential typology, unit typology is fully IBS. We proved that it's 100% IBS, so tick, right? And then every single component members are all IBS member modular glazing units, special elements such as framings, structural walls, including the furniture inside, yes, the built-ins. And with Gamuda, throughout the workshop that we did, we understand that even the toilet is being built separately by pods, which is actually a volumetric model by itself. So that is how the whole composition of our volumetric model, which is becoming one set of the cubes. Yeah. Sustainability, we put a lot of focus in it, but I'm not going to go in detail about all the elements of OTTV, glass, paneling, or whatever. So the big idea of the whole sustainability ideas that we have is about the people. So we're trying to create all this space which is going back to the community. You see, we're creating all this communal hallway for people to interact, which we actually innovate the space and giving back to the people for healthy living. So whatever, all the spaces within is actually talking about that. So again, sky terraces for people, becoming a place for people to wind around, you know, and then sky garden creating with all the green and water body for microclimate, cooling the space within. So it's more towards that. And also just a piece of maths for you to share with you guys. If you were to calculate our green area on the ground plane minus the footprint of the building, and if you add back all the green area that we have, we're actually giving you 105% of green spaces, more than if they don't want to build anything. So we're giving more green area for people, right? Okay, as much as we want to blur the spaces between the public and so the private, we're also keeping certain level of privacy. Every single unit if you can see, is linked by a secondary bridge to their unit. So the common corridor, common hallway becoming spaces for public, for residents in general. Yeah? But to go to your unit will be separate bridges. Again, materiality, this is what we are proposing now, precast concrete. But we are also sharing this idea that living cubes can be anywhere in the world. So if you were to build this in Indonesia, we can use timber. Almost there, yep. And if you were to build this next to Bilbao Museum, you can go for copper, metal is a good contrast probably. And also you can also go for bricks. Okay, so the whole idea of living cubes, okay, it's all about creating these quality spaces for inhabitants. Okay, it might look very straightforward, but it's all about elevating the quality of life. Socially, we want to enhance that. We want to elevate the lifestyle, quality of life. In other words, to promote healthy living. And the most importantly is living cubes is soothing in the eyes. It's nice for people to see, I think. And also to draw people to live in. And for Gamuda, or any developers here, entice people to own it. Thank you very much.
Good evening, everyone. So, yeah, this set of slide is not the actual slide that we presented to developers. So this is sort of like behind the scene kind of version of the slides. Okay, so if you have the experience of living in one of those stratified high rises, you know that you are actually sort of living in a submarine, meaning that you're going to enjoy the view maybe for 5 minutes, and you're going to enjoy the interior of your house or stay inside for the rest for next 10 hours before you go to work again. So sometimes you go to your window and peek outside, and then maybe you see something. So and you retreat to the interiors that might look like this. So or more closer like this. Okay. So we know that they don't look good because they are not designed together. I mean, the clothes are designed by someone else, manufactured by someone else, the house designed by someone else. Everything are designed by a lot of parties. And this is a problem where we saw that the things inside your house is a byproduct of industrial design or product design, and your house is sort of like architecture or spatial design, which is a problem of architecture trying to contain more progressive art, which is industrial design, in the sense that they move faster, they innovate faster. You might own a house for 35 years to finish up your loan. By then you have like thousands and thousands of clothes already. So we thought that the battle will be in the interior, okay? Obviously not, compared to evident by the first two, where people actually enjoy their home. But to do this competition, we kind of have to do a bit of architecture. So we kind of do the external or the architecture part as a vessel. Of course, the architecture will contribute back to the interior, and you will see how. I think this is not new. Again, there's some movement like this still that try to curate everything, from what kind of art you could have in the house to furnitures. More extreme example, every element is a functional element. The floor, the wall, and the orientation is not that important. I mean, when the space station rotated, it still works. And the most important thing is, as astronaut goes up there, they can update certain modules. They can do renovation, okay? And we are also heavily influenced by IKEA. And this is like our small office. This is IKEA Aiva, which also more or less built on the same system. We use it as a partition or wall kind of thing. So if you have a typical unit, which the wall has plaster on both sides, you're going to have this footprint taking up the space that you bought. So if you buy a 900 square feet house, you might be able to enjoy 750. Okay? So on top of that, you add furniture. And now it increased to this 450 footprint. and then further reducing your 750 hard-earned square feet into maybe, I don't know, 600 or even less than that. So what we want to do is that we want to get rid of all internal walls and then use furniture as high-performing elements that has function and also divides the space. So, okay. So they could be updated by the sections, just like your app. Some apps has frequent updates, some don't. So it is more or less thinking about how to create that dimensional stability so we can change them and also update them where we need to. We look at product design, industrial design, where each component will have their own specific function. In this particular case, we're proposing even customized HVAC unit, customized kitchen unit in order to get the house running. So we propose, this is not in the original slide, okay, so we propose Gamuda to be more vertically integrated. Now they are in this tree business. They just recently go into IBS, building component manufacturer, of course. We asked them, maybe they can go down here into interior and furniture fittings and whatnot, and go down to utensil and appliances. Okay, so you can see the scale. So the model is more or less like Red Bull. Red Bull like do everything, even though it's an energy drink company, but they have a F1 racing team. They have school, they have fashion line. They have, you know, almost every business, there will be a stain of Red Bull. So it will look more or less like this. Gamuda branded spoon, with Gamuda branded spoon container, with Gamuda branded, I don't know, cutlery base, in a Gamuda made cabinetry, and of course flooring. So it became clear to us the idea is not really architecture. We don't really actually care about the physical look of it, because based on this idea, they can like go wherever they want to go. It's not proposing an architecture, it's a mass domestic architecture, the way to think about mass domestic housing. So that's why we don't submit a project. We submit a document, which we call Gamuda New Housing Framework, GNHF. So there is few principles, but I was just going to focus on these three, which is the first one. We will make the interior free of any wall, so you can move your wall, okay? We will make furniture as wall. So I create this term, super net. I'm sure you're familiar with carpet area, but carpet area does not deduct the amount of space that furniture occupy. Super net is like the actual space you're able to enjoy. So like 900 square feet apartment maybe you can enjoy. Actually, you can enjoy like 400 something square feet. And the last one is standardization. Everything is built by one manufacturer rather than multiple manufacturers. And of course, using BIM as a tool to cut wastage. So we start with this after visiting their plant. We know that there is certain dimensional restriction, and we start to, you know, just go crazy what we can do with this modulated dimensions, and eventually we go with this because it has such a low profile, and also the idea of making it a little bit more permeable. So I think we'll just skip this. It doesn't bear much significance. This is the side. Of course, this is the sort of courtyard house, courtyard block we're trying to do. The car park will be on the ground and the first floor, fronted by shops or retails. And this is how the units look like. We have 20-something units, but since we are a small practice, so we're gonna simulate only one. Okay, so we're gonna show in detail one of those units. So the block is not that high. You can see that the shop frontage on the ground. This is the bridge connecting to a nearby MRT station. And then it goes up another few stories. So the whole thing is only 8 stories. It's very low. And the pixelated facade, you can see that they are helping to shade one another. So this is how it looks like. It looks very interlocking, and you can see that each unit will have at least two small balcony. This is like 2 meter by 2 meter, I think 2 meter by 2 meter. It's quite huge. And even though everything is made of similar volumetric mass, at certain point where the corner meets, it creates this quite special silhouette that almost make it look like it was organically designed, and then softly dissipate to the sky. Okay, the facade, which is one of the important part. One way to do it is to use volumetric structural component, and it will look like this. Of course, knowing the question that will come after that, we make a economical version where we include sort of a composite panel, which is include a steel structure there, so that we can have the load go directly down. The idea was to make sure that the steel structure blend together with the rest of the window frame or window wall frame. This is more economical version. Obviously, this is RC flat panel with 2 fenestration, and then try to address the load on the cantilevered part. This is like versions which they can scale up or scale down. Eventually, the range of sort of catalog will look more or less like this, as a range of how much uninstructed view do you value your uninstructed view. So this is like you choosing your periscope. Certain periscope is clearer than the rest. Certain periscope has more range than the other. This is the middle part, which in the particular courtyard basically rose from level 2, 4, and up to 7. So just after this floor, this is already sky. So it's not like super. It's not going to be dark, first of all, and you can enjoy a range of facilities in this particular floor, which goes up to level 3, 4. So you can be connected at all time to your common facilities, regardless of where you are. So, for example, the playground is at level 4. It's connected to the common corridor on both sides, which almost all of the neighbors can, have a view of the children. And of course, surau, management office, barbecue pit, etc., etc. The components, they are just that. And then the beam, which, I think all of us know, we don't have to talk about that too much. And also the interior portion. We actually try to build a range of interior components as a family, and then in order to get the idea of mass fabricating them through a base of framework. So this is the basic, version 1.0 of those framework, okay, with different depth and width. And basically all these things, just based on this particular set of base, we can create doors, sliding doors, folding doors, cabinetry, wardrobe, and what else. The possibility is infinite. So when you're done, you can pick and choose, put into a house. It's sort of like play dollhouse again. And basically after you're done, it will look something like that. It's a bit full up. You can see that how the actual permanent wall is just the external party wall, and also the bathroom. And eventually, if you are thinking of moving out to somewhere, or you want to let go of your parts, you can switch it up. If you buy another G&A house somewhere, you could bring your component there as well. Or you can sell to your neighbors, because it works. The architecture is designed to conform to the framework, so it will not have that 5 mm, 10 mm left over. If you do, just silicon. They are also designed in the zigzag shape in order to give you the best opportunity to get your sunlight, everything that is needed under UBBL, of course. Okay, ways to do it. We're actually teaching them how to do it. Of course, if you have all these regulatory document, you cannot easily change your things, right? And also, of course, you don't want to be binded by the layout because, you know, residents tend to change their mind. If you, in SPA, the shape is like this, then suddenly they have two child while waiting for the building to be completed in 3 years, then it's quite hard. So we say the SPA will have, you know, the same drawing as per the BP drawing. Gonna be like basic empty unit, and we're gonna supplement that with a benefits package, just like your pantry, your aircon, whatever things that developer gave these days, right? And we're gonna give them a credential. We also make a fake app, by the way. So you can log into the app, but we don't have a QR code, sorry. So let's say mother-of-2@gmail.com with password. You can choose whichever. Okay, let's say in this particular case, we show your PBT, the locality, and then eventually the neighborhoods. Let's say it's Haibujaya. And then choose your unit. Of course, you can, like, you know, orbit through. Okay. And then after that, you can choose your pre-made layout, because we know that not all of us are, not all of us have the time or have the expertise to customize our own home. And then based on that pre-designed layout, you can like go one section by one section and pick out your fit out. Okay, so you could do this, I think, yeah, even when the VP is almost nearing, you can like confirm last minute. And then what happens is that the information will go into a server, and then we have to create an interface between that survey thingy into a BIM software that can be read by Gamuda IBS factories to cut the planks, okay? And you can install on site. Yeah, like honestly, it could be almost anything you could imagine. So it has a longer lifespan in terms of, it could be an office even, a startup office, I think we showed one. And the idea is, knowing now the market is so slow, the idea is to create a product that have a little bit of flexibility in terms of positioning. You can position as a co-housing, you can position as a transit house, whatever you want to call it, with the idea of having this flexible layout. Yeah, I think that's it. Yeah, thank you.
Okay, Villa Loca actually means as what you see in this sketch. So what we wanted to do was something quite simple, a simple gesture, which is to build a high-rise over a mound. Of course, the major issue of this competition was actually to look at the housing issues in this country, but we were given a make-believe site. So, which is fun, because we don't usually get to design based on a make-believe site. But we did study of what not to do. As you see, the examples of current Malaysian requirements in terms of housing and what we have at the moment in our public housing. Villa Loca is actually a compilation of units, and in terms of a high-rise over a mound, that we wanted to encapsulate all the other facilities that we have at the bottom. So basically, in terms of the site, I think I want to go through a bit of the site. Even though it's make-believe, it's actually quite similar to any Klang Valley situation. You have an MRT station on one side, you have a park on one side, and a neighborhood on one side, and a more densely area on the other side. So what we did not want to do is to build another type of typology with a high-rise on podium, because land area is actually a major consideration in this country. So what we wanted to do is actually to build a tall building, a smaller footprint over the site, giving it a much better usage and giving back to the public on the ground level by giving the lush greenery in terms of lush greenery in terms of mounds and open spaces. So that area was actually going to make the space more for the placemaking for the drop-offs, large area for the public to gather, and also we created areas for the other facilities in terms of amenities, shops, and so on and so forth. So the idea is actually to cover the rest of the other facilities with a mount, giving back to the public in terms of the neighboring park and also the placemaking. The other part of the idea that is important is actually the placement and orientation of the area, of the site. The placement of the tower is made specifically to be on one corner of the site, where the public space that we have created will be shaded in the afternoon. In terms of the position, it has to be in that particular corner. And to address the urban design of this area, we have created this pathway in terms of a canyon where it travels across from the MRT station and the neighboring park over to the other side, in terms of to bring people across and utilize the site. So pedestrian walkways and commercial drop-off are being linked together in terms of how to address the entire site planning. This is a closer look at the drop-off area in terms of the incoming of the site, in terms of the commercial drop-off, to bring people across from the MRT station all over to the other side. And we also have the back door where the loading and unloading happens. I think the major issues that we try to address, or the main idea, is actually to have a concept of duality. On one side of the apartment, we have the conventional apartment, which is colored in red. But on the other side, we try to explore the idea of rentable pods of co-living, because the idea of having units to be sold and be owned is actually a Malaysian mentality. So what we try to explore is actually to have the rentable pods to coexist within the same building. These are some of the factors of why we have this rentable pods idea, because of the shared economy, the rise of millennial, rapid urbanization, and also high cost of property. And these are some of the familiar brands that creates the gig economy in our time today. In terms of the other factors, we have more expensive houses and units becoming smaller, and therefore we created this idea to coexist in terms of between the two parts of requirements. In terms of the floor plan, yes, you can see here on one side we have created the conventional apartments, where the other side is actually the living pods for the co-living. So the colorful dots that you see here are actually interchangeable living pods, which is about 300 square feet or so. And it is served by a central core, like normal for a high-rise, where one side is actually serving on the conventional apartment, and the other side is serving the rentable pods. And these co-living spaces are actually traversing the entire tower on one side, where you have the shared living spaces, which is going to be enjoyed by people on this side of the tower. These are some of the spaces where people could enjoy in the co-living parts, where you have the public spaces, shared kitchen, living rooms, library, and so on and so forth. And the idea that we tried to sell was this area, in terms of the entire height of the tower, could actually be maybe bought by one single investor, and they rented the entire thing, or a quarter of it is being sold to another investor for maybe student accommodation or something like that, or the other part could be actually for rental purposes. These are some of the layouts. But for us, the layouts are very important in terms of what it can be. These are fixed structures, and this could be very flexible layout, and it's interchangeable. As you can see here, you have the external living spaces, and you have a 2-bedroom situation, or you can have a 1-bedroom situation. And at the same time, the idea of the pods could actually be expanded into a bigger unit if you need to. If you expand the units, it's going to be from the smaller 300 square feet, it can turn into a 900 square feet layout. So these are some of the ideas that can work in terms of the flexibility. Just a picture of the layouts. For the conventional apartment, we feel that the layouts are, again, needs to reflect how people live. For example, in this country, the units with 3 bedrooms as what is required in the brief, but we pay very close attention to how the units are done in terms of having places for drying clothes, places for like a balcony or a lanai, and all the 3-bedroom needs to have external view rather than looking into a void. And these units are also designed with the IBS in mind, which is a requirement, and also offer some flexibility, which I'm going to show you later. A 2-bedroom unit also have the similar idea, and in terms of openings and light and ventilation, we have all the units to have both sides fenestration. Layout flexibility is another key idea of this tower, where you have all the items in red are the structural elements, and the rest can be built out of lightweight material, and that can be interchangeable. For in terms of flexibility in layout, in terms of the typical units, that could be changed and replaced if you need a bigger open plan layout or a bigger living and dining. Things can be modified as you go along. As far as the layout flexibility is concerned, you have the typical units expanding outwards, and also the living pods expanding sideways to occupy the other spaces. The other part that is very important for this tower that we created is actually the common spaces. These are the spaces that is created in between the two parts of the building, where on the one side where the conventional apartments are, and the living pods, and the space in between, the cracks, if you will, were filled up with these public spaces, where it can be used for gathering and also other type of activities that can be used by the occupants. And those spaces can be used as collaborative spaces, creative, educational, for children, for adults, and so on and so forth. Of course, one of the requirements is sustainability in terms of energy usage, but we would employ another sustainability in terms of financial sustainability, which is all the other facilities that has been created at the lower floors could be rented out, as well as an observation deck that people could charge a ticket to get up there. This is a view from the observation deck, where this is something similar to what Pinnacle at Duxton in Singapore is doing, where they charge $6 per entry to go up to the 50th floor. IBS is also, as you learned this evening, that all the requirements in terms of the competition needs to be built using IBS component. But in our case, in Malaysia, IBS generally means it's precast concrete. So what we try to push is something a bit further, which other countries have already started. In Malaysia, the concrete precast IBS, we are struggling in terms of lifting it up into higher floors. When you start to build anything beyond 30 stories, it becomes a problem in terms of logistics. So what we wanted to do is to explore in terms of a more hybrid type of prefabrication. But however, we are using the system that Gamuda has to offer in terms of the precast slab, staircase, windows, facades, wall panel. But at the same time, we are using also the co-living pods as a hybrid system, which is a combination between concrete and steel. And also the precast PBUs, they call it prefab bathroom pods. For example, in Australia, people are building 60 stories prefab apartment units using a hybrid system, which is a combination of concrete and steel. Of course, we had to go through the IBS system design, where you have the structural component, the slab, the columns or structural shear walls, the precast walls, the PBUs or the bathroom pods, and the windows and facade systems. This is also another element of a prefabrication, not in concrete. And also the mechanical and electrical system, where we work on the beam model. Yes, it's just scoring. And the how it's put together in terms of all the things coming together, in terms of M&E and walls. And of course the numbers, we had to meet all these elements. And I'm going to play a little bit of animation. No, it didn't work. Right on cue. Thank you.
Thank you very, very much. It was a beautiful presentation. Let's have a round of applause for all our speakers here today.